Hello, good day. The title of our project is Development of Hybrid Nanomaterial for Improving Crude Oil Extraction. Crude oil has remained the dominant sources of energy, usually for automobile, aeroplane, heavy duty, and many other equipments. Because of the increasing populations and level of industrialization, this has necessitated the supply of uninterrupted energy. However, most of the oil reservoirs have been abandoned, probably due to limited technology to extract the residual oil after exhausting all methods. So the objective of our study is to develop the hybrid nanocomposite that has the ability to influence reservoir properties, such as interfacial tension, wettability, and also to improve crude oil. So in our methodology, we deployed a design of experiment where we generate series of different combinations of the nanoparticles. These nanoparticles were then combined with water and cyclic to pre-treat the nanomaterial. The nanomaterial was subsequently treated with other reagents, and then solid product was obtained. So subsequently, the product was further characterized to understand the chemical interactions between the composite nanomaterials, such as FTIR, FISM, and crystallography. After that, also we formulate the nanofluid, which is a base fluid that can be injected into the reservoir. So we started by checking the viscosity, as you can see from the first image, and then check the interpartial tension, and then also investigate the contact angle. So in this experiment, we conducted the core flood experiment, which is basically the practical simulations of crude oil displacement, where we injected the nanofluid into the system to observe how it influences the reservoir properties and how it improves the oil recovery. This is one of the significant aspects of the project. So our result shows that there is significant linear relationship between the input materials with the composite nanomaterials to the yield of the product. As you can see, about 95% of the yield was obtained. So the chemical interactions between the composite materials was investigated using a spectroscopic experiment, and we can see that significant interactions were observed, particularly in the first image. And then in the second image also, we noticed that the material has already retained its crystal properties, which is the crystalline properties. And when we investigated the internal structure of the molecule or of the compounds, we noticed that the compound still maintain its cylindrical shape, as you can see from the image, and it has the average size within the nanoscale. So the elemental compositions were also further investigated to see the compositions of these elements, and in particular the modified halocite nanotube. We notice it contains the cerium nanoparticle as well as silver nanoparticle. Investigation into the interpartial tension reduction revealed that modified halocite nanotube reduced the interpartial tension significantly better than the pure halocite nanotube, and about 41% improvement was observed at 500 ppm concentration. Similarly, the wettability alteration investigation revealed that the modified halocite nanotube reduced the contact angle, which is one of the important properties to release crude oil from the reservoir. So this showed that modified halocite nanotube has more effect than pure halocite nanotube. In crude oil displacement experiment, we observed that the modified halocite nanotube generate more differential pressure. This differential pressure is one of the important properties to influence the release of crude oil from the reservoir. And we noticed that about 23% of crude oil was recovered using modified halocite nanotube, better than the pure nanotube. So you can see from the image the amount of crude oil being displaced using these two nanoparticles. So in conclusion, this study successfully developed modified nanotube and significantly offer several benefits in relation to EOR, which could be an interesting material for oil and gas market. Thank you.